Okay, our goal today is to determine whether a relationship is a function or not a function. So let's start with the definition of function. A function is a rule in which every input has exactly one output. So let's talk about what an input would be. In kid terms, an input are all your x values and your output are all your y values. So if we rewrite the definition using our own terms, we could write every x has exactly one y. So every x has exactly one y. That's our definition of a function in math class. So inputs. Well, inputs are known as x values. You might have heard them in elementary school called domain. Outputs are your y values. And in elementary school, you might have heard them called the range. So we might use the term input, we might use the term x value, we might use the term domain. Those are all synonyms of each other. For output, we could say output, y values, or range. They're all synonyms of each other. So let's practice this with different relationships. How can we tell if a table is a function? We said for every x has exactly one y. So let's look at the x's. 2 has a partner. 6 has a partner, 11, -1, -4, and 8. They all have one partner listed as a y value. So this is a function. And the only reason you ever want to write is each input has exactly one output. Each input has exactly one output. Let's look at this table. We have 2 goes to 6, 6 goes to 8, 11 goes to 15. Wait a minute. Look here. 2 is now with 9. He started with 6, and now he's partnered with 9. So this is not a function because look at that x value. And the reason is when x equals 2, y is 6 or 9. We can only have one y value for each x. So it can't be a choice between 6 or 9. That's why this is not a function. 2 went with 6 and 2 went with 9. So that's how you check from a table. Let's look at a list of points. Well, remember when we write points, we write x, comma, y. So there's our input, the x. Our output is the y. So let's underline all our inputs. We have an input of 4, a 7, a 10, and a -3. Well, that never repeats, does it? So I don't have to worry about there being a problem because the x's don't repeat. So this is a function. And we said the only reason we ever write when it's a function is every input has exactly one output. Let's look at our second list. I'm going to again underline all the inputs, the x values, so I can keep them straight. I have 4 goes with 5, 7 goes with 9. 4 is going with -2. Look at that. 4 has 2 different partners, so this is not a function. And the reason is when x equals 4, y is 5 or -2. So that's how we can tell from a list of points. Now let's take a look at a mapping. It's also called an arrow diagram. The first bubble is always going to be your x, and the second bubble is always going to be your y. That's how you can tell. First is your x, second is your y. Well, 7 is connected to -2, so he's only got one friend. 8 is connected to 0, only got one partner. 9 is connected to 5, only has one partner. So each x only had one partner, so that's all good. So this is a function, and our reason is every input has exactly one output. So let's look at our next arrow diagram. If we look at 7 this time, look, he's partnered with 0 and with 1. That's not allowed in a function, remember? Each x can only have one y. So this is not a function. When x equals 7, y is 0 or 1, and we're not allowed to have that. Well, let's take a look here at a graph. Okay, in graphs, you got to remember which is the x-axis and which is the y-axis. The x-axis is horizontal. It goes straight left to right, and the y-axis goes up and down. It's vertical. So these are all my x's. If I look at every x and I take it up to the graph, does any x have more than one y with it? Nope. So this is a function because every x only has one y. Every input, or x, has exactly one output. Let's look at this next graph. Remember, x is our horizontal and y is our vertical. So if we look at all our x's, if I go to this x, he's got a point up here on the graph and and a point down here. Well, what about this x? Point up here, point down here. So if we look, this can't be a function because lots of x's have more than one partner. So not a function. Many inputs have multiple. I don't want to list them all, so I'm going to use many and multiple. Many inputs have multiple outputs. That way I don't have to list every single one of them. Well, what about with an equation? These are equations. Here's how you're going to be able to tell with equations. Y does not have an exponent. So if y does not have an exponent, then it's a function. So y, there's no exponent listed, is there? So that's a function. And our reason we know something is a function is always every input has one output. And then if we look at our second equation, y still? Because remember, this is a coefficient, not an exponent. Exponents are those little numbers. So this is still a function. Function. Every input has one output. Now I want to take a look at something a little bit different. If we look at this table, I want you to think for a minute and tell me if this is a function or not. Is this a function or not a function? It's actually a function because we don't care how many partners y has. We only care how many partners x has. X is allowed one partner, and each of these x values only has one partner. Every input has one output. Let's take a look at one more example using a table, and then you'll move on to your own practice. So here's my table, and here are my numbers. -2. Take a look at this table. Is that a function or not a function? Well, I see that the input repeats, doesn't it? This 3 repeats. But this 3 has the same partner both times, doesn't he? 3 went with 7, and 3 went with 7 again. So this is still a function. Every input had one output. Just because he saw the same output more than once doesn't matter. Every input has one output. It's still a function. All right, go ahead and you can use the extra videos if you still need some help on understanding this topic, or you can move on to the practice.